To this point, the quadratic equations that we have solved using completing the square have been of the form x squared plus bx plus c equals 0. In each case, the lead coefficient a, which is here, was equal to 1. To use completing the square technique for the equation ax squared plus bx plus c equals 0, where a does not equal 0 or 1, simply divide through by a and proceed as you did before. So we just divide each term by a and then proceed as we did before. By dividing by a, the result is an equation that looks familiar. Now use substitution and let 2k equal b over a and c equal negative c over a. And the result is an equation that you have solved a dozen times or more in previous exercises. We end up with x squared plus 2kx equals c. So complete the square and we get x plus k squared equals c plus k squared. Solve by completing the square. The first thing we're going to do is divide each term by 3, which is the lowercase a coefficient. That gives us x squared plus 4x minus 22 equals 0. Since we can't factor this, we're going to move the 22 to the other side. So we're going to add 22 to both sides. And we're going to complete the square on the left side. 4 divided by 2 is 2. 2 squared is 4. So we have to also add 4 to the other side because it's an equation. Both sides must remain equal. Alright, so we have now a perfect square, x plus 2 squared, and that equals 26, which we can just go on to solve as usual. Let's also go through step by step. So the first step was to divide each term by 3. The second step was to add 22 to both sides so that we're left with just x squared plus 4x on the left. We complete the square on the left side and then immediately add 4 to the other side as well to keep both sides equal. Then we turn this into our square and solve as usual.